Dear all, wish you a very good day. In the previous few lectures, we have studied about two methods. One is X-ray tomography and one is nuclear magnetic resonance imaging, which were utilized for detection of bones and different organs and body fluids in our body. The present lecture is focused on even a more better methodology, that is ultrasonic image system. Now, the present system is with respect to the sound, how detection can be carried on. Okay, in the previous lectures we have seen two different methodologies. One was based on the X-rays and the other was based on magnetic and RF imaging. This methodology is based on sound. So let us look at the ultrasonic imaging systems and discuss about its properties and so on in this lecture and henceforth. So ultrasonic imaging system. Diagnostic ultrasonic is now applied to obtain image of almost all the internal organs which are in the abdomen. Okay, so just below our rib cage is our abdomen area, and ultrasonic waves or ultrasonic imaging system is utilized to observe and detect any deficiency or any discrepancies in the organs in the abdomen area. Okay, ultrasonic waves are sound waves which are above audible range, that is 20 kilohertz. Okay, audible frequency is in the range of 20 hertz to 20,000 hertz, so that amounts to 20 kilohertz. So physics of ultrasonic waves. Let us look at the physics of ultrasonic waves. Ultrasonic waves can be easily focused. So these waves does not have any problem, and we can focus them in a specific area to detect any part. They are inaudible and suitable for application where it is not advantageous to employ audible frequency. So humans cannot hear this frequency, therefore they do not affect humans in any adverse ways and can be employed instead of audible frequencies. By using high frequency ultrasonic waves which are associated with shorter wavelength, it is possible to investigate properties of very small structure. Okay, since their wavelength is very small, therefore they can be utilized for investigation of very small structures, because larger the wavelength, their bending around the structures is more, and therefore they will not make a clear image. But since ultrasonic waves have shorter wavelength, they can generate a much more clearer image or structure. In dynamic studies, the information obtained by ultrasound cannot be acquired by any other more convenient method or technology. Okay, so there are many of the components which we can see in real life, and we can observe their activities in real life, how they are functioning, and this is not possible through any other method at such an easy or convenient way. Ultrasound use longitudinal modes of the wave propagation. Okay, so as there won't be stresses and curves, crests and troughs, but there will be rarefactions and refractions. That is, somewhere their frequency will be closed and somewhere their frequencies will be further apart. Then comes properties of ultrasound waves. Okay, like other form of sonic energy, ultrasound exists as a sequence of alternating compression, refraction, rarefaction of a suitable medium, okay, with a suitable velocity or with a suitable frequency nu. Okay, so there is a suitable frequency and there is rarefaction and compression of these waves. Okay, quite similar to frequency modulation in the FM technique that we have observed or we might have studied in earlier classes. Then its behavior also depends on the frequency of sonic energy and the density of medium through which it propagates. So medium is very important part in ultrasonic wave detection, and properties and behavior of ultrasonic waves greatly depends upon the medium through which it is propagating. Okay, and frequency is also dependent on the same medium. When a beam of ultrasound wave passes from one medium to another, portion of sonic energy is reflected and remainder is refracted. Okay, so some energy similar to the light, as light hits a mirror, some of it is absorbed and some of that is refracted and some of it is reflected back. In the similar way, ultrasonic waves also get reflected and refracted from different human organs which are present. The amount of energy reflected depends upon the difference in the density between the two mediums and angle at which the transmitted beam strikes the medium. So very similar to the methodology of light reflection. Okay, so it depends upon the angle at which the waves are hitting and density of the medium through which they are being reflected back. The greater the difference in the medium, the greater the amount will be reflected back. So depending upon the density, more waves will be reflected back and less will be refracted inside the medium. Where Z1 is one medium, Z2 is one medium, angle of incidence is theta, then angle of reflection is also theta. Okay, so based on this we can calculate characteristic impedance of the medium, which is given by Z, and it is equal to rho V, where rho is the density of the medium and V is the velocity of the sound in the medium. The reflected energy in the form of percentage is given by Z1 minus Z2 whole upon Z1 plus Z2 whole square into 100%. Ultrasound wavelength and frequency relationship is given by V is equal to n lambda, where V is velocity of the light, n is the frequency, and L lambda is the wavelength. Ultrasonic frequency for medical applications are in the range of 1 MHz to 15 MHz. Depth of penetration of ultrasonic waves depend upon the velocity of the sound in the medium into time, and this is divided by 2. Okay. Then comes effect of frequency. Okay, with the increase in the frequency of sound, wave becomes more directional, and so acceleration resolution improves, and attenuation is increased with frequency penetrating, and frequency penetration decreases. Okay, so as frequency is increased, okay, waves become more and more directional and therefore axial resolution increases. So along the axis resolution improves. However, attenuation also increases with the frequency, and penetration, that is the depth to which ultrasonic waves can go, decreases. Okay, axial resolution, attenuation increases and penetration decreases. This is shown. Next lecture we will be focusing on generation and direction of ultrasound waves and their principle and their medical applications. This is all for the present lecture. Thank you.